Hi, hello, who are you? My name is Anna. Welcome back to my channel. I am going through as many LeetCode problems as I physically possibly can in a year, and we are on question number 99, recover binary search tree. That was my first time reading it. This solution is going to be in Python, and I've done 2 other solutions today, and my brain is, I need to do one more just to make sure I don't end on a super rough note. But the solutions were good, it's just my brain is having a hard time getting kick-started. So, without further ado, let's go on to question number 99, which solution is going to be, the solution for this is going to be in Python. So, recover binary search tree. Okay, you're given the root of a binary search tree, BST, where the values of exactly 2 nodes of the tree were swapped by mistake. Recover the tree without changing its structure. So they give us examples here of 132 and 312, the input 13002, 310002. 3 cannot be the left child of 1 because 3 is greater than 1. Swapping 1 and 3 makes the binary search tree valid, and it's the same here with this 3142 and up here with the 2143. This would not work. 2, it says right here, 2 cannot be in the right structure of 3 because 2 is less than 3. Swapping 2 and 3 makes the binary search tree valid. So, we have the constraints here. The number of nodes in the tree range from 2 to 1,000. It's a lot. Solution using ON space is pretty straightforward, I would agree. Could you devise a constant O1 space solution? I can try, but I cannot make any guarantees. But this reminds me of another question. I think I did it for LeetCode. I can't remember. Yeah, I think I did. Where instantly I want to use Morse traversal method to identify the misplaced nodes and swap them out. So, and since I don't use that often, it was for another similar, eerily similar binary search tree question. Pretty sure it was only a few questions ago, but I did take like 5 days off. So let's begin. We're through the question one more time. So you're given a root of a binary search tree where the values of exactly 2 nodes, exactly, not 3, of 2 nodes of the tree were swapped by mistake. Recover the tree without changing its structure. So, let's start with, I do think we should do this Morse traversal idea. So, let's start with some variables, right? We know that there are exactly, not at least, we know there are exactly 2 misplaced nodes. So I'm going to say first misplaced, which at this point we're going to say none. We're going to do second misplaced, which is also going to be equal to none. Now the first and second misplaced are mutable container lists used to store the 2 misplaced nodes. So they are initially set to none, and we are also going to do the previous node, which is also mutable container, but we are going to have it store the previous node that was encountered during the in-order traversal. So we initialize that Sentinel node with a value of a negative infinity. That is going to be how we're going to do that. And that will handle the case where the mistake is at in the root. So from here, I'll say, I'm going to put this in first really quick. Float negative infinity. Okay. Yeah. So from here, we're going to start that in-order traversal because that's the only way we're going to be able to work. So let's say we have a in-order traversal function, and it's recursive to process the binary search tree node from left to right. So we're going to say node, and then we're going to say if not node, then return, and in order traversal for the left. From here, we need to compare that current node with the previous node, which, so if not the first misplaced, so let me say if previous node is value is less than the node value, then if not first misplaced, then the first misplaced is equal to the previous node, which means the second misplaced is equal to node. And then we can then say we update the previous node to node. And then that will be for the in order traversal right node. So then we start that in order traversal from the root. So we're going to say what can we say? In order traversal root and then we swap the values of those misplaced. So it's going to start with first and second equal second and first. So first misplaced value and second misplaced value is equal to, and this is lazy programming, but we don't talk about it. I'm not going to type it all out. Okay, because we don't need to return anything, we just modify it, which is why I'm doing this in lieu of saying return this, this, and this. So that should work. So essentially, we're using this to identify the two nodes using Morse traversal. That's the tweet. And then we swap that and we store it in the correct structure. So we correct that tree. This should actually execute this pretty efficiently. So let's run it and see if I have any errors in it. Global name in order traversal is not defined. Huh. So, what do you mean? In order traverse. Oh, there's no S. There's no S. It's like, what do you mean? It's right there. Oh my gosh. I literally copy and pasted it so I didn't have an error. Dumb. Why do I do this? But you know what? It's running. It's testing, right? So the logic is there. Morse traversal coming in clutch. Okay. So I feel good about this. I feel like this is good. Also, I want to show you guys I haven't submitted anything for this yet. But we're about to. Yeah, let's go ahead and submit it. Ooh, that's not very good. Okay, so it looks like we're going to be redoing this problem eventually. I beat 60% of users with Python in runtime, but 10% of users with Python in memory. Guess I technically could have seen that coming. Technically. Yeah. But you know what? We live, laugh, love in the condition we're in, okay? It's like almost 1 o'clock in the morning, because I've had a lot of stuff to do the last couple of days. So you know what? We will come back tomorrow, rested and refreshed. It's supposed to rain most of the day, so I'm hoping for that to be what keeps me in. So I will do my 100th problem. It's not actually my 100th problem, but it is problem number 100. I have done 130 something odd LeetCode problems over the last 3.5 months, but I'm excited to do that tomorrow. So thank you guys so much. I'm going to leave this code in the GitHub repo down below. You guys are more than welcome to fork and clone it, make it better, make it worse, have some fun, learn something new. Recommendations on how to make this better, we'll happily take. And I will see you guys in the next video. Thank you so much for watching.